Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This video is for my algebra class, lesson 2-7, probability of compound events. Okay, in this lesson we will be finding the probability of independent events and dependent events. Okay, so here are our vocab and key concepts. The probability of two independent events says that if A and B are independent events, the probability of A and B is equal to the probability of A times the probability of B. In other words, independent means that they do not affect each other, and we'll define that here in just a moment. The probability of two dependent events, if A and B are dependent events, the probability of A then B is the probability of A times the probability of B after A occurs. Okay, so to clarify just a bit, independent events are events that do not influence or affect one another. And as you might guess, dependent events are events that influence or affect or depend upon each other. All right, so let's look here at an example concerning independent events. Hang on, let me try to get this focus a little better. I apologize. Okay, this one is about independent events. Suppose you roll two number cubes. What is the probability that you will roll an odd number on the first cube and a multiple of 3 on the second cube? Okay, so the probability of an odd would be 3 out of 6 or 1/2 when I reduce it, because there are 3 odd numbers out of 6 numbers. The probability of a multiple of 6 is 2 out of 3 because there are 2 multiples of 3 out of the 6 numbers. That reduces to 1/3. So if I want to find the probability of the first event of the odd on one cube and a multiple of 3 on the other, I'm going to take their product. So the probability of odd is 1/2 or 1 out of 2. The probability of a multiple of 3 is 1 out of 3. So I'm going to substitute in and multiply, so that gives me 1 out of 6. The probability that you will roll an odd number on the first cube and a multiple of 3 on the second cube is 1 out of 6. So basically you're just taking the probability of each of those independent events. One cube does not affect the other, and then you're going to multiply. Okay, let's turn to example number 2. Selecting without replacement. Now this means that the events are going to actually be dependent, because you're going to change something after the first event occurs. Your sample space is going to change. So suppose you have 3 quarters and 5 dimes in your pocket. You take out one coin, but you do not put it back. So that's crucial. You do not put it back. Then you take out another coin. What is the probability of first taking out a dime and then a quarter? Since you do not replace the first coin, the events are dependent. Okay, so whatever happens with the first event does affect what can happen in the second event. Okay, so first of all, there are 5 out of 8 coins that are dimes. So the probability of a dime when I first draw is 5 out of 8. Okay. The probability of a quarter after a dime, there are 3 out of the 7 remaining coins that are quarters, so this is going to be 3/7 or 3 out of 7. So the probability of a dime and then a quarter is the probability of a dime, 5 out of 8, times the probability of drawing a quarter after you've drawn a dime, 3 out of 7. Nothing to cross cancel. 5 times 3 is 15. 8 times 7 is 56. So the probability you will take out a dime then a quarter is 15 out of 56. Okay? And again, those were dependent because your sample space changed in the second probability because the coin was not replaced. Okay, you have a couple of quick checks here, and then I'm going to skip ahead to the examples. Remember, you may do the quick checks whenever you choose, now or at the end, because you can always pause the video to go at your own pace or however you feel most comfortable. Applying probabilities of compound events. A teacher must select 2 students for a conference. The teacher randomly picks names from among 3 freshmen, 2 sophomores, 4 juniors, and 4 seniors. What is the probability that a junior and then a senior are chosen? Okay, so there are 4 juniors among 13 students. Okay, so you get the 13 by adding 4 and 4 is 8 and 2 is 10 plus 3 is 13. 4 of them are juniors. So the probability of choosing a junior is 4 out of 13. Now the probability of picking a senior after a junior is 4 out of 12 because there are 4 seniors among the 12 remaining students. Because once you pull a kid's name, you're not going to put it back in. It doesn't specifically say that, but think about it. If you've drawn a name out of a hat and they're going to a conference, you can't put that name back in there to draw again. It wouldn't make sense. Okay, so 4 out of 12. So the probability of drawing a junior then a senior is 4 out of 13 times 4 out of 12. Okay, you can cross cancel here. So the 4 goes into itself 1 time, pardon me, and into the 12 3 times. So 1 times 4 is 4. 13 times 3 is 39. So the probability of a junior being drawn and then a senior is 4 out of 39. Okay, there are a couple of more quick check questions after this on page 40 of your notes. So again, please have all of the quick check questions answered before we meet again in class. I look forward to seeing you then.